So this is going to be more of a pictographic view of what goes on in the citric acid cycle. And we have a little pre-citric acid cycle stuff at the very top along that arrow. And once we get to the oxaloacetate, that actually begins the true citric acid cycle. So there is kind of a difference. If you look up in a textbook or something, you'll see that the citric acid cycle starts with the oxaloacetate, not with the pyruvate. But first, we need to take that pyruvate and turn it into something that we can use to put in the citric acid cycle. So pyruvate is a C3 molecule. It undergoes oxidation, which reduces the NAD plus to NADH. The next thing it does is it loses a carbon atom. And it loses that carbon atom by oxidation in the form of a CO2, which we exhale. So that CO2 goes off into the world. We breathe that out. The C2 then that is left moves to the CoA or coenzyme A, which attaches itself to the C2 to make acetyl-CoA. Now the only reason why it's attaching there is because there's an empty spot on it, and that empty spot is taken by the CoA. Until it hits oxaloacetate, then the CoA is no longer needed, and the oxaloacetate, which is a 4-carbon molecule, bonds with the 2-carbon molecule to form a 6-carbon molecule called citrate. So this is the beginning of the citric acid cycle, this formation of citrate. The citrate is then oxidized, which reduces NAD plus to create NADH, which is used in the electron transport chain. The new molecule that is produced there loses a carbon atom in the form of CO2. So now we have a C5 molecule. This molecule is called alpha-ketoglutarate. The alpha-ketoglutarate undergoes oxidation to reduce NAD plus to make NADH. It then loses a carbon atom in the form of carbon dioxide to create a C4 molecule. That C4 molecule turns ADP into a TP, and now we have succinate, which is a 4-carbon molecule. That succinate will oxidize and reduce the FAD to create FAD2, H2, FADH2, and now we have fumarate, which is also a 4-carbon molecule. That 4-carbon molecule will undergo hydrolysis to create malate, which is another 4-carbon molecule. The malate will undergo oxidation to reduce NAD plus to create NADH. We then have oxaloacetate. So that oxaloacetate will be reacting with every single incoming acetyl-CoA produced from the pyruvates, which were produced from the glucose, which we started with. So you can see this cycle repeats over and over and over and over again. We end up with much more high energy particles than we started with, and those high energy particles, the NADHs and the FADH2s, will be used later on in the electron transport chain to create even more ATP.